Part 6, the table method for graphing transformations. This slide is from part 2 of the 1.3 videos. These are the steps we're going to use. Step 1, add c to each x coordinate. Step 2, multiply the x coordinates by 1 over b. Step 3, multiply the y coordinates by a. And step 4, add d to the y coordinates. Let's use this method to sketch a graph of f of x equals 5 minus square root of negative 1 minus x. We need to decide what a, b, c, and d are. So I'm going to rewrite this as negative square root of negative x minus 1 plus 5. Then we can see that a is negative 1, b is negative 1, that's the coefficient of the x, c is negative 1, and d is 5. So let's follow those steps. We'll start with just the square root of x. So if we have the square root of x, 3 points on the square root of x are 0, 0, 1, 1, and 4, 2. If I were to graph just the square root of x, I have 0, 0, 1, 1, 4, 2, and the graph is this shape right here. Now let's see what happens if we use this table method to transform these 3 points. So we'll do one thing at a time. First, we're going to look at the square root of x minus 1. So this we know moves it to the right one. We're going to think about this as adding 1 to all the x coordinates. So all the x coordinates of these points are going to add 1. So I have 1, 0, 2, 1, and 5, 2. Notice I'm doing nothing with the y coordinates on that step. The next step would be to divide by b or multiply by 1 over b. So that would give us points on the graph of square root of negative 1 minus x. So I'm going to divide the x coordinates by 1 over b. So 1 over negative 1 or negative 1. Now I have negative 1, 0. 2 divided by negative 1 is negative 2. And 5 divided by negative 1 is negative 5. The next step would be to take care of the a that's in front. So we're going to multiply the y coordinates by a. And that's going to give us the negative square root of negative x minus 1. So we multiply all of the y coordinates by negative 1. 0 times negative 1 is still 0. Negative 1 times negative 1 is negative 1. And negative 1 times 2 is negative 2. And then the last step, so we're going to do the negative square root of negative x minus 1 plus 5. Now we're going to add 5 to each of the y coordinates. So negative 1, 5. Negative 2, 4, because negative 1 plus 5 is 4. And negative 5, 3. Negative 2 plus 5 is 3. These are the coordinates now on our graph that of the original function we wanted to graph, 5 minus square root of negative 1 minus x. So let's graph those points. We have negative 1, 5, should be about right here. Negative 2, 4, should be about right here. And negative 5, 3, which is about right here. So if I sketch my graph, it looks like this right here. So let's make sure this makes sense with what we know about the transformations. We know the negative in front of the x moved it across the y-axis. We know that it got flipped upside down because there was a negative at the very beginning in front of the square root. We know it got moved up 5, so I see it moved up 5 there. And we know it got moved, it got moved originally to the right one, but then when we flipped it over, now we're at negative 1, so our vertex is where x is negative 1. So this seems to make sense with what we know. Another thing you could do to make sure you have right points at the end is to substitute in the original equation negative 1 for x and make sure you get 5 for y. Sub in negative 2 for x, make sure you get 4 for y, etc. That would just be a double check of how to do this.